कुछ नहीं. Hello, I'm audible now. Junaid and Zainab,
Yes, sir.
please switch
Audible.
on your videos. Just. Yeah. So in the last class, we have started the dispersion of light, right? So let me connect it. Zainab, are you there? Zainab also, are you there, dear? Zainab, please respond at least, dear. I'm not able to hear you. Yeah.
Yes, sir.
Okay.
I did
Check.
respond.
Acha, check. Okay. Okay, so in the last class, we have started the dispersion of light. So dispersion of light means that the splitting of white light into its constituent color due to the different speed in the glass medium, right? So I've told you about that. How does the you can say this? You can say the deviation will occur. I've told you that you can say wavelength is inversely proportional to the frequency of the light. Okay. And according to that, I've also written the order of frequency. So it means that we can easily identify which light will deviate the most and which light will, you can say which color will deviate least, right? Zainab and Junaid, is this clear?
Yes, sir.
Yes.
Okay.
Yeah.
Now let's consider. So now it's time to understand that suppose now the white light here, just a second here. Now the white light is split into 7 constituent colors. Suppose that I will place a prism right here in an inverted position. Now what will happen? Let me know. What will happen? Any idea?
Beam will go from violet to red.
The beam will.
The beam will start from violet to red.
Zanam, your voice is lagging there. Please speak again.
Sir, the beams will go from violet to red.
Will go from in how, like, I'm not getting your point. Like beam will go from violet to red. Is it get it?
Like it'll be reversed. I don't know. I'm just
Acha,
guessing.
acha.
That's it.
Acha. You are saying so it will get reversed. Check it. Junaid, yes, go ahead, dear.
I don't think we'll be able to see it anymore, but I'm just guessing. I don't think we'll be able to see it anymore. But,
You are saying that it will become white light?
no, we won't be able to see it. It's like dark. Basically.
Acha, dark. Check. Okay. Correct. Okay, let me tell you what will happen. So when the light splits into 7 colors, and if you place an inverted prism just in front of the band, or you can say spectrum, what will happen? The white light will converge, will recombine to form the 7 colors will recombine to form a white light. This is called recombination process. Okay, Junaid and Zainab, is this clear?
Yeah. Yeah.
Sir, I don't get
Got
it.
it?
Can you repeat?
Okay, I'm saying, this is the white light which incident on the glass prism, right? After that, it got dispersed due to the different speed in the glass medium, right? That's why this band of color is formed. And if I place an inverted prism just in front of it, so these light will converge and form a white light. This is called recombination process. This is dispersion. This is recombination. Clear, Zainab? Clear, Junaid?
Yes, sir.
Yes.
Okay.
Yeah.
Sure, that's good. Okay. So let me write down the you can say the process word. The 7 colored lights of the spectrum can be recombined to form and give back white light. Clear? Zainab and Junaid, is this clear?
Yes.
Yeah.
Okay. Sure, that's good. Okay. Now let's move to the new thing. Okay. That is the rainbow. This is the real world application of the you can say the dispersion of light. Okay. The rain. Clear, everyone? Okay.
Yeah.
So basically, what do you mean? Okay, so now tell me, what do you mean by rainbow? Have you seen rainbow in real life?
Yes, sir.
Okay, chalo, that's good. So when does the rainbow form?
Due to the water droplets after
No, I'm
like
asking.
After rain.
Okay,
After rain.
after rain.
after rain.
Check. Okay, so basically, in this case, the water droplets act as act as which kind of thing?
Prism.
Present. Okay, Junaid?
I think the gym as well.
Yeah. So basically, the water droplets suspended in the air after the rain act as a tiny prism, and each water droplet disperse the light. That's why we see a rainbow in the real life. Okay. Second thing that you can see in the that you can see the rainbow. So, like you've heard about the waterfalls, Niagara Falls, and like there are multiple falls. Waterfalls are there in India itself and in other regions of the world. So what happened is that when the you can say when the water falls near the waterfall, basically the water droplets, the very fine water droplets, or you can say mist of things, basically suspend in the air and they act as a prism, and that's how the rainbow is formed in a sunny day as well. Okay. So
I
water.
have a doubt.
हाँ बताओ please ask me.
So, sir, if there are many water droplets, that means there are many prisms. There are many prism. That means doesn't the white light wala thing happen
अच्छा,
like
no
again?
basically okay देखो what happened is that you are saying the same, you are saying that कि देखो your two water droplets are there and one water
Yeah.
droplet will basically reflect. So देखो, let me show a picture to you. How does it happen? Because the thing that you are getting confused, and let me show the picture. This happens, but the very small amount of recombination happens in the real life. Let me show you the picture of the rainbow. There. Is this visible? So sunlight is coming from the sun and basically it refracts because outside is air, inside is water. So basically there is a change in medium, so it will refract. Yes. So after refraction, as you can see this thing that white light splits into 7 color due to the different speeds. Okay. So after this, the light ray directly comes to the eye. This happens, and the recombination happens at a very smaller like you can say at a very smaller stage, not that much amount of you can say recombination happens. Okay, because it should be a certain criteria to recombine the light. Okay, because in this prism we have a certain criteria that you have to, you can say, invert it but water droplet is a circle. How you can place it? Right. So in this case, we can easily identify, but in the water droplet case, it's very, you can say, tough to identify whether it's happening or not. So there is a very small chance. Okay. So that's why most of the time this happens. Clear? The rainbow.
But it can happen, though, right?
It can happen though. Yeah. Obviously, this
Okay.
is nature. So there is some certainty as well. Right. Okay. Okay. So now let's understand. Okay. Now just a second. Let me write down the definition first and then I will write down the. So basically, if you talk about the rainbow, so what rainbow is? So the formation of the rainbow is just is an arc of 7 colors. Visible in the sky.
Sir, how long does the dispersion of the rainbow stays for?
It depends. Maybe it depends on the water particle for how long they're suspended in the air. Because the water particles will not be suspended for a long time because when the sun comes out, that they will evaporate. Okay.
Oh, okay. Thank you.
In the sky, which is produced by the dispersion of sunlight by raindrops in the atmosphere. Clear? Clear, Zainab and Junaid?
Yes.
Sure. Chicken. And the reason is that a rainbow is produced by dispersion of light. Okay. Dispersion of white light by what you can say by raindrops in the atmosphere and each raindrops act as a tiny glass prism. Okay. Splitting the sunlight into spectrum. Clear? So C part is the raindrops in the atmosphere basically will act as a prism. Act like act like many small prism. Please let me know, is this clear to all of you or not?
Yeah.
Any doubt so far, Bicho? So this is the rain.
Sir, what question would they make if they had to make from it?
They will directly ask that what is rainbow, how does it form? Okay. And they could ask that in terms of rainbow, why the violet light is in the, you can say, is deviated most and why red light is deviated least, or they can ask directly in the rainbow which light is deviated least and which light is deviated the most. So obviously the dispersion, so basically in rainbow or in the dispersions, both the context are same. Okay, because the light which have the higher frequency will deviate the most and which have the lower frequency which deviate the least. Clear? That's how they can ask the question. Like in this chapter, there's not the questions are not that much. You would say tough or complex. You cannot twist that much because these are completely based on the real life words. Okay. So, written all of you.
I got it.
Check. Okay. So that's good. Okay. So let's do a little. Let me check. Okay. Please mark the correct one and let me know the answer in the chat. Jaldi se. Hello, Mariam. Assalamu alaikum.
Walaikum salam, sir.
How are you?
I'm fine, sir. How are you?
I'm good. Why are you so late, Mariam? It's almost like it's exactly half hour late in the class.
Sir, net issues.
Chalo. Okay, so Zainab said violet and the second one is red. Violet. Chicken. Okay, Reba. Okay, Mariam, I have started like I've just taught the rainbow part. Okay, so this class is recorded. So please go and check out the recording after the class. Okay. Yeah.
Yes,
So the
sir.
next topic that I'm going to start is atmospheric refraction. That is completely new. So just only I have taught this part, the combination and the rainbow part. Okay. Now this is
Yes,
the
sir.
numerical. Okay, this numerical is based on the previous topic that we have done. That is dispersion. Okay, so you could easily understand. Acha, let me know the answer. Mariam, you also let me know the answer by your side. Which answer you would like to tell me? Which one is correct? I'm giving you 1 minute.
Sir, I should type.
Let me know in the chat.
Uh,
Which has the maximum speed in the glass prism and which one has the least wavelength. The answer, Mariam?
yes, sir.
You will जल्दी से answer करो. चलो देखो. The color light having maximum speed in glass prism. So maximum speed in glass prism is that the light which will just a second. Pen got stuck. तो देखो ये तो simple सा है which of the second वाला which of the following which have least wavelength. So least wavelength means which has the highest frequency. So highest frequency is of violet. यहाँ पे मैंने last class में आपको बताया था. I've told you that the order of frequency and order of wavelength. So order of wavelength is basically smallest for the violet, right? So and high length longest for the red. So the second case is violet. Okay. Now, so we have Vibgyor. Okay, let me write it here to understand this one. Vibgyor. So this is the order of यहाँ पे मैं इसको frequency ले लेता. So we have this is the order of frequency. This ठीक है यहाँ पे frequency blue, green, violet and yellow. Blue, violet, green and yellow. So the question is saying that the wavelength, the maximum speed. So maximum speed means the light will deviate the least. Light will deviate the least because deviation will occur. This is the refraction. So the light will deviate towards the light color which deviates the most towards the normal will be having the least speed, and the light which basically deviate least will be having highest speed. So blue, green, yellow, or blue, violet and green, these are having highest frequency. So it means that wavelength would be less, and it means that it will deviate more than the yellow part. So yellow is the correct answer. Violet is not the one that is having the maximum speed, it will be the minimum speed. Violet will be having the minimum speed. Clear, Zainab and Junaid and Mariam?
Yeah.
The second part that you have
Yes,
got
sir.
is correctly, absolutely right. But the first part, is basically, that's why I have written the order of wavelength and order of frequency, because whenever the whenever there is violet and red, so obviously either could be one answer, because violet is maximum frequency and red is longest wavelength. But apart from violet and red, there, suppose that only one is present, like violet in this case. It means that you have to remember the order. So just there is no like nothing to remember. Only you have to write it. Your an order of frequency will be like this. If you have to change for the order of wavelength, so you just have to use this side. Clear? The longest wavelength will deviate least, and it will basically, you can say it will be having maximum speed. Clear, Zainab, Junaid, and Mariam?
Yes,
Yes,
sir.
sir.
Okay?
Yes.
So these kinds of questions will be there in the exams for MCQ in this topic. Got it?
Yes,
Okay,
sir.
sir.
Okay. So, chalo, that's good. Okay, so now let's do. Actually, I've also given homework to all of you. The MCQ questions in the last class. How many of you have done the questions?
I
Mari,
just,
Zainab.
I just sent it.
You did also?
Yeah, no, I just sent it like
Acha, ठीक है.
30 to
Mariam?
30 minutes ago.
Okay,
Sir,
Junaid. Okay, that's
sir, I
right.
didn't do. I will do.
Mariam, it seems like you're a little bit lethargic since your exams are over. It's true, so?
Um,
I know that vacations are going on, like you have got recent like vacations recently, but it doesn't mean that you are going to be inactive for the tuition classes. You have to be very active, right? Because right now
yes, sir.
school is off. You just have to do the you can say revision and the homework of the school, like of the Learnivio. And the homework I gave you, it's very 2 or 3 questions or 4 questions. In the last class, I think so, I have given 5 questions, and these were MCQs, totally MCQs. No need to solve it, just you have to mark it right or wrong. Right? Yes or no? Junaid and Zainab. Okay. Chalo, okay. So let's write down the new topic, that is atmosphere. Okay, Mariam, got it? I hope you will not let
Yes,
down
sir.
me from the next class.
Yes, sir.
Chalo, what happened? Do you have any internet issue, Mariam? Still?
No, sir, it's good now.
It's good. So please switch on your camera.
Yes, sir. One
Check.
minute.
Oh. Okay. So now the next topic that we are going to study is atmospheric refraction. Okay. Okay. So this topic is basically not mentioned in CBSE syllabus, but this could be a reason that it is considered as a real life application. So that's why I'm teaching you this topic. Okay. So I'm not sure whether, because CBSE didn't mention this topic specifically. Okay. So this topic lies under the real world application. So that's why I'm doing this. So if this topic is there in your syllabus, that is well and good. If not, you can skip it for the syllabus, because when your school will teach you, you will get to know properly. Okay. So, but still we are doing this topic because I don't want to take any kind of risk for that. Okay. Because sometimes school says, yeah, this topic is not there, but after that suddenly the questions appears in the exam like a genie. So, so that's why I don't want to take any risk. Okay. Clear, Zainab, Junaid, and Mariam?
Yeah.
Sure, that's good. Okay, now let's understand what basically atmospheric refraction is. So basically, you must have heard about this. So just let me draw something. Suppose like this is atmosphere. So our atmosphere do have many layers. Like I don't know the proper sequence of the layers. One is troposphere. Troposphere is the lowest layer, I think so, which is the just above our head. Troposphere. Okay. So troposphere, lithosphere, mesosphere, stratosphere. So these are the layers of the atmosphere. Do you remember this thing, Bachu? Like basically I do not remember this thing because I've never learned about like I learned this thing in the 6th or 7th standard, but after that I haven't heard this thing about in the whole student life. Okay, so these are the layers. So basically every layer have different density. Every layer will have different density. Okay. So, sorry for the mispronunciation. Okay, just a second, like this. Okay, like this. Okay, so this is total is called atmosphere. Okay, and this is suppose toposphere. Okay, this is lithosphere. Okay, this is mesosphere and all this thing. I don't know the order properly and no need to understand remember the order as well. I'm just telling you. So every layer have different density. So if we have different densities, it means that light will refract according to the density. We have studied this thing in the refraction of light that every medium will refract the light as per the density. Yes, Junaid?
Can I turn off my camera for a second?
Check. No issues.
Thank you.
Welcome. Okay. It means that every layer will refract the light depending on the density, because देखो, refraction will be different for water, air to water, and refraction will be different for air to glass. So both have different densities. Mariam, Zainab, and Junaid, yes or no?
Yes, sir.
Okay. So that's why it's very important to understand why does it happen. So basically, refraction that occurs due to the Earth atmosphere due to different densities provided by a single layer is called atmospheric refraction. Okay. So, so basically, from the start to end, the densities basically will increase. The starting layer will have the least density, and the lowest layer will have the highest density. Clear?
Yes.
You must have heard that when you go on the high altitude, you may not easily breathe the air. You're not able to breathe properly. Have you heard this thing when you go on high altitude?
Yeah. Anyone
No.
has.
Okay. So I have been to the you can say mountains. So they are very complex. Suppose that basically we live on the plains. Basically, Delhi is a plain area. Okay, and suppose I went to Kashmir in 2016 and 2021 in my vacations for the holidays. Okay, so I have seen this thing that when we go on the top of the mountain, or you can say top of you can say small mountain, we are not able to breathe properly because the oxygen is very less at high altitudes. Okay, so it means that the density of oxygen is very less there. But on the normal plane, just like we do in Delhi, I can easily breathe because the density of oxygen is very much high. So the density increases from top to bottom in the atmosphere. Clear? So this is an example that I'm going to give you. Clear, everyone? Any doubt so far? So similarly, atmospheric refraction will happen because the densities will increase throughout the atmospheric layer. Clear? So that's why it will refract the sunlight or any kind of light that is coming from the outer space to the atmosphere. Clear?
Yes, sir.
Sure, that's good. Okay, so let me write down the definition first, and now we will. Okay, so basically two you can say phenomena are there. First phenomena is twinkling of star. Second phenomena is advanced sunrise and delayed sunset. You must have seen that so basically when we wake up in the fajr, so basically the sunrise the rays becomes you can say like rays become very visibly like very visible in the like around 5 p.m. Rays are very visible, but actually the sunrise is not you can say the sun is not on the horizon, it is below the horizon is the line which basically meets the sky and the you can say ground. Okay. So sky and ground is the point. This is called horizon. It is not an actual line. It is an imaginary line. Okay. So we see this thing that the sunrise is happening, but actually sunrise is beyond, like it's below the horizon. Okay. So we will do this thing in the atmospheric refraction phenomena. The first point about atmospheric refraction is that sorry for the mispronunciation. Sometimes I stammer a little bit. I don't know why, but this happens to me suddenly. Okay, so sorry for the mispronunciation. Okay, there. caused by. And this is the reason my family basically like laugh on me. They say this thing, you have to speak, or like you have to learn how to speak. Okay? So so they basically they make fun of mine. Like sometimes happen, I don't know what is the specific reason behind it. Maybe due to the humidity or something like that. I don't know properly. Okay. Atmosphere having air layers of varying optical densities is called atmospheric refraction. Clear, everyone? Zainab, Junaid, and Mariam, is this clear?
Yes, sir.
Yeah.
That's good. Atmospheric refraction. Okay. Now, next thing is that the reason behind is I've told you that the varying optical densities throughout the atmospheric layers is the reason behind atmospheric refraction. Okay. Densities in the same atmosphere. So in the same atmosphere, multiple types, or you can say varying densities are there. Yeah. In the same. Clear?
Yes.
Sure. Okay. Next thing. Okay, so we will now let's understand the phenomena in the atmospheric refraction. The first phenomena is twinkling of stars. Okay, so have you like I think so everybody has seen like this twinkling of stars. Is there anyone who has not seen? Hmm? Anyone? Is there anyone? Okay, Mariam, you didn't see. You haven't seen yet.
Sir, I saw.
Okay, you saw. Acha, acha. You were saying like that. I thought that you hadn't seen it. Zainab, have you seen the twinkling of star? Okay. Okay. So basically, twinkling of a star is not the basically it's not like it's not actually happening. Like they do not twinkle at all. The reason is that the first reason is that it is due to the atmospheric refraction. The second reason, the main reason, basically, the continuous change in the atmosphere, the densities that continuously changes basically increase or decrease the amount of light coming towards the eye. Okay, so that is the reason the we see this thing that the stars are twinkling due to the increase and increase and decrease of the amount of light refracting towards the eye. The sudden change in the in the refraction, the amount of refraction, causes the twinkling effect. Okay? Everyone clear?
Yes. Yes.
The sudden change in the amount of refraction causes the twinkling effect. Clear? So that is the reason behind the twinkling of a star. The first reason is that obviously this lies under the atmospheric refraction. The twinkling of star is due to the atmospheric refraction. Acha, let me know whether a star produce their own light or they reflect, just like just like the moon does.
Stars produce their own light.
Okay. Okay. Yes, they are luminous objects.
What's the answer though?
Yes, yes. Yes, Janam, you are saying something?
But then what's the answer though? What's the right answer though?
They produce their own light.
Okay.
They are luminous objects. Okay. Luminous objects are those objects which produce or emit their own light, just like stars and sun. Okay. Moon is a non-luminous object because it does not produce its own light. Instead of that, the moon reflected. Okay. Okay. So next thing is that B part. The continuous changing atmosphere refracts the light, okay, by different amount. From one moment to another. To the next. Okay. The starlight reaches the starlight reaching our eyes increases and decreases. Okay, just a moment. Okay, after this class, bacho, you have an assessment. So please go and check out the assessment. Okay. So just decreases continuously due to atmosphere. Refraction. The stars appears to be. Here, everyone, Zainab, Junaid, and Mariam.
Yes, sir.
Yes, clear.
Sure, that's good. Okay. Okay, so the reason is that okay, so there could be one more possibility that suppose that star twinkles. Why does planet do not twinkle? Why does planet not twinkle? What is the reason that planets do not twinkle? Any idea?
They're non-luminous.
They're not
Uh,
going through the atmosphere to a region, so we're too close to them for them to think.
Okay, so and okay, Mariam is left only. Zainab said they are non-luminous. Junaid said they are very closer to Earth. And okay, so Mariam, there is another reason from your side. No,
Sir, I'm not sure.
chalo, theek hai. So both the reason that we have given, Zainab and Junaid, are correct. First reason is that they are non-luminous objects. They cannot emit their own light. Okay, so the light coming from the planets are basically is of very low intensity. The light is not that much you can say observable. Okay, because stars to have their own light, so the light coming from the star are very you can say is of very high intensity. Okay, so that's why we could easily observe the twinkling of star. But in case of planet, they do not twinkle at all, because the reason is that they do not have their own light, so the intensity of the light is very small. Okay, and the second reason is that they are very close to Earth, so the light coming from them do not refract that much to observe the twinkling effect. Clear? Okay,
Yes,
everyone, is this clear?
Yes, sir.
Any doubts so
yes,
far?
sir.
Okay, so this is the next. Okay, so the plan why does planets do not twinkle is the part, and the advanced sunset and delayed sunrise. Sorry, advanced sunrise and delayed sunset is left in this topic. Okay, so we will do this thing in the next class, bacho. So I request to all of you, please go and check out the assessment, and you have to revise on a regular basis. Okay, I hope so in the coming week you will be having a weekly test. I'm not sure about it, but I think so. Clear? Zainab,
yes,
Okay,
Junaid, and
sir.
Mariam.
yeah.
Clear?
Yes, sir.
Zainab, I'm so sorry, dear. I just forgot to basically schedule your extra class, backup class. I will schedule in the
Yeah,
next
I was
week,
about to say that
surely.
now.
Yes, I will surely schedule it. Yeah, I just forgot it. It's completely out of my mind. I'm so sorry for that.
Okay, it's
Yeah.
alright.
ठीक है? Okay. I will basically I will schedule your class before the coming class. ठीक है? Because your
Okay,
week is
sir.
completely occupied. Just like you have physics today, you have I think so chemistry on Saturday or Sunday. Then you will be having maths classes as well. So your week is little bit occupied. So I will
But
schedule
then there's like
on
no day.
yes
But then
yes
there's like no day in which I have like two classes.
okay within 4 weeks, within 4 days.
No, like my whole schedule, right?
Hmm.
There's not a single day in which I have two classes in one day, so you could like take some time.
Okay, okay. So, okay, ठीक है, I will schedule because the reason is that I do not schedule two classes in a single day because sometimes students skip it. Sometimes, so that's why I haven't scheduled it. If you are saying so, if you're you can say comfortable with that, I will schedule it. ठीक है?
Yes, sir.
चलो ठीक है. So
Okay, sir.
this is all for this class, everyone. Thank